Hello everyone, today I'm going to talk about slabs, one-way slab and two-way slabs and how we design each one. I show you a plan of slab here. The long direction is Lx and short direction is Ly in x and y coordination system. If Lx on Ly or long direction to short direction is over 2, in general we say that it is one-way slab. So what one-way slab means? One-way slab means that if we have loads on this slab, for one-way slab, it is going just for 2 directions and there is no load applied on the short direction, on the other short direction here. And in two-way slab, depending on the size, that definitely it is just Lx on Ly equal or just less than 2. We have load applied on 4 sides. So let's go for reinforcement in one-way slab. In one-way slab, we are going to have just primary direction to be reinforced for strength and deflection control. It means that if we provide reinforcement for just short direction, that is section of Lx here, the reinforcement will be okay, will control the deflection and strength required for load applied in the long side. So I've shown here 2 types of reinforcement. The red one here is just bar for strength and deflection control. If we, depending on the supports, in general we have tension reinforcement at the bottom and some compression reinforcement or tension for negative bending at the top, depending on the, if we have some restrictions for moment, we may have some negative bending, and in that case we may have some reinforcement for top side as well. But in general, if it is just simply supported end beams, simply supported end side of our long direction, we have just bottom reinforcement for tension and that's enough. And again, I say that if we, for one-way direction, if we control deflection in just one long, the short side, the between long sides, it is enough. We don't need to check deflection in the big side between L in long direction. And if we just check deflection in Ly direction, it is okay. And also if we check the reinforcement required for Ly direction, Ly length, it should be okay. And also, so by now we don't need any reinforcement for strength and deflection in long direction, longer length or just shorter direction. But we may have reinforcement for shrinkage control as well. You know that we have 3 types of shrinkage control. It is just minor, moderate or high crack control, and for that one we should apply reinforcement on top and bottom side. So for reinforcement for strength we need just bottom reinforcement and also top for negative bending if we have. But for shrinkage we will have top and bottom reinforcement in both directions, in x direction and y direction. So definitely for this one we will have just one reinforcement for shrinkage, but for the short one, but for Ly we will have reinforcement or strength and crack control and deflection and also crack control. So for this direction we just compared the reinforcement required for strength, deflection and shrinkage, and whichever is bigger we put that in that place. So if we want to control for shrinkage, deflection and strength, definitely we will have top and bottom reinforcement here and top and bottom reinforcement for other direction. But remember, for if we don't need to check for the shrinkage control, we don't need to put any reinforcement in Lx or in the short direction. So let's go for two-way slab. In two-way slab, Lx and Ly ratio is less than 2, less or equal to 2. Same, we will have primary and secondary direction, and we need to have strength and deflection reinforcement for both primary and secondary directions. I've shown you here. The red one is just for strength and deflection. It doesn't matter Lx is primary or Ly is primary. It is just your choice. Whichever is just, you can put secondary or primary, and it will change the effective length that I will talk later. So you have reinforcement for strength and deflection for Lx that you're putting here at the bottom, and again for top in negative bending area if you have, and for this other direction you're going to have this reinforcement and the other direction at the bottom below the main reinforcement for this direction. And this is the same arrangement, but from the other view. That long reinforcement here are just showed here as like outward, and the same these ones are equal to this red long direction. And again, for shrinkage control, depending on if we have minor, high, or just moderate crack control for shrinkage, we will have reinforcement in both directions at top and bottom. Again, depending on the crack control reinforcement required, we will check it with the bars required in that direction for strength and deflection, and whichever is bigger, we put that. So the same here, if we consider crack control for crack control reinforcement, deflection control, and strength control, we will have top and bottom reinforcement in both directions in each way. The only thing that we need to be careful about in two-way slab, if you take primary and secondary direction, that is just optional. You can take Lx primary or Ly primary, and the other one will be secondary. Just remember, in that case, your effective depth for reinforcement in one direction should be bigger than the other direction. See here, D1 is bigger than D2. The shorter D1 or smaller D2 will affect the capacity on the other direction, in that direction for phi mx or phi mu, or just reduced ultimate bending capacity. And also it is effective in punching shear capacity if you have punching problem. Just be careful, you have D1 and D2, and for each direction you will have different moment capacity. Yep, that's all for one-way and two-way slab. And just you remember, you will have different regulations for moderate, minor, and high crack control in different standards, but their general rules are the same. You will have just one direction for strength and deflection control in one way, that is always short direction, and for two-way slab you will have check for deflection, check for strength, and check for shrinkage in both directions. And just be careful that you will have primary and secondary direction that will change your effective depth for reinforcement and that will cause the value of bending capacity. Thanks for listening and sharing this video.